This conference will now be recorded.
Hello, friends. Welcome back to the next session. So, in the previous session, we were discussing about the practical understanding of data science. So, we conducted a demo session to understand, what are the connecting pieces of data science, where all the work happens. And one important thing we understood is that modeling is not the only piece which data science is involved. There are other components which will help the data science journey uh, to be more realistic. In the real world, there's a lot of work happening. So in our course, our focus is to make it more realistic. Thanks for joining it. For the next few days, we will be just doing some basics of data science. So today's session will be on applications of data science, and going forward, we'll get into what is machine learning, and then we'll discuss about in the next week we'll discuss about Python for data science, and going on so forth. So to just understand data analysis, so data analysis has been there for a long, many years. There are a lot of work happened in the data analysis space. People have uh, created quality controls. There's a lot of work happening in intelligence systems. Then there was AI, which was coined. Then there was work on machine learning, and a lot of big companies have evangelized data and data analysis. So this is not a pretty new term. This is a very old term. Now, what has changed, during that time and this time is there are few things which has changed. So there were a lot of efforts in evangelizing AI for many years, but they also went into something called as AI winters. In the early 1950s, there was effort in which uh, the perceptrons were invented. Perceptrons are like the basic building blocks of neural networks. We'll learn about them when we learn deep learning. But they are the basic building blocks of neural networks, and they were invented, but because there was unavailability of data, the first AI winter came into picture around 1970s, 1975. Later, there was another hype cycle. The hype cycle said that, now we have data, now let us do processing on images, identify handwritten digits, and so on. So, early 1980s, 1990s, there was another hype cycle. But later in 1999, 2000, that era again, it went into AI winter, because even if the data is available, there was not enough compute. Compute in sense, you should have infrastructure to run a lot of computation. That infrastructure was not available. Now we are in this phase. Now this is a little old presentation, but as you see, we are exactly this question mark right now, 2023, where we are doubtful whether it is going to become another hype cycle, right? Are we going back? Whether this bubble is going to burst, or there was excitement, but it's not a big, great thing, so it will be pretty much flat, or there will be a lot of excitement. There's a lot of applications being done. Now, we don't know. This future will decide, but we have to think about couple of things. Now, the things which failed in the previous past are the reasonings because of unavailability of data, unavailability of compute. Now, what happened is there are three things which came into picture. We have good amount of data, we have good amount of compute, and also we have good amount of algorithms. Now, what is algorithms? I would say, for example, you might have heard about Chat GPT, right? All these days, it's a big buzzword right now. So Chat GPT is kind of a language model which helps us to uh, train data, and then based on the data, you could operate the chat interface where you can ask questions and then it will answer in much more intuitive way. So your questions can be as crazy as possible. I hope you guys have tried and tested it. If not, go log on to chatgpt.openai, something like that. It would be a website link, and then you can try it out. Now, with the advancement of algorithms, we now have ability to use data and produce great results. You can produce phenomenal results in which you can develop deep fakes. You can produce phenomenal results in which you can create applications which can produce chat-based interfaces. We also have applications with respect to voice and other things as well. Now, that gives us a positive hope, right? It's not going to get into this again a hype cycle and a bubble burst phase, but either it is going to sustain or it is going to get into this excitement stage where there will be a lot of more applications which are going to create in the future. If you see, many of the companies are trying to make their companies as AI fueled. Now, what I mean to say, the AI fueled is like AI becomes the back engine to push the organizations forward. They have tested and they have tried and tested lot of other options, but now with the advancements of AI, they are trying to rename their companies as AI fueled, right? AI fueled, AI fueled bank, AI fueled company, AI fueled retail, AI fueled some XYZ joint. So you see, all those names are coming up. And the reason for all this thing is that there is a tremendous amount of availability of data now, thanks to computers, internet, mobile, and all that stuff. Now we are able to capture data very quickly in a precise manner, and we can also do a lot of data transformation in a quick manner. So all those things are possible because of availability of data. Now let us see, if I say data, what are the different types of data which is available? Generally, the traditional form of data which is used in industry, we call it as transactional data. Transactional data is like your regular information which is captured. Suppose say you are a retail company, regular information captured by the cashier or the manager for the transactions which happened. Those that you can term it as transactional data. Maybe a retail company buying rice or sugar or oil or something. So you would like to capture all these transactions, and then you store it typically in databases, relational databases, and then you do some queries to fire that analysis on those tables. This is a typical transactional data, and you see like 80% of business data is transactional in nature, so that most of the data gets captured and you operate on that data. But recently there is a lot of advancements in other forms of data. You might have heard audio data, your Alexa, your Siri, your Cortana, all these things, right? They are basically accepting your audio information, and based on that there is a lot of processing happening. If you think how Alexa works, Alexa has to hear your voice, decode it, convert the voice into a text based format, fire the queries on the text based format, return the results of the text based format, and then again convert it back to voice. So you see, there are a lot of sub steps in which this entire data transformation is happening. but audio data is more prevalent in the recent years. You can also have experimental data. Experimental data is all about conducting experiments. You might have heard COVID-19. There were a lot of experiments happened, and based on that, they were able to create the vaccine, and we know all that. We know what happened and all that stuff. So all data pertaining to that, we can term it as experimental data. Other kind of data forms, for example, video and image data, are also very popular these days because video data is helping us to do video analysis. Then image data is like analyzing the images and using the images for um, some kind of analysis. So those are the different types of data which is available. Apart from that, people also create some other kind of graph, charts, and stats to visualize this information and to provide this information in much more clarity way. Next, we'll get into the understanding of what is artificial intelligence, machine learning, and deep learning. Now, artificial intelligence, if you think, it is more like an umbrella term. So you can think it like it's covering the entire machine learning, deep learning space. It is a generalized term in which you can say like, how can I use a computer to make the work of humans? So initially, artificial intelligence was created to make humans' life easy. Are there any tasks which humans are spending a lot of time, they're manual and then repetitive? Can we convert that manual and repetitive task to be performed by computer? That was the first effort, right? So there are a lot of these manual tasks. You can think about this automation, right? Now people call it as automation. Now, automation is one time called as AI also, right? So you have these set of tasks which are manual and repetitive, and then you can write a logic by which computer can do the work of human. That generally is typically coined as artificial intelligence. Now it is easy if the number of records are less, if you can easily understand the pattern so that you can create formulas for that, you can create if then else rules for the data. But what if the number of records are more? What if the data is huge? The number of variables are more, and it is humanly impossible for to create all the rules, right? So in that case, people started using computers for identifying the rules. So people use statistical techniques so that the machines can extract the rules and then can create something called as an algorithm which can do certain predictions. Now that is called as machine learning. So in machine learning and artificial intelligence, if you see, artificial intelligence is a general term, whereas machine learning is more specified when the data is huge. We are not able to extract the formulas, or we are not able to extract the relations and patterns. So we use computer techniques, specifically statistical techniques, algorithms, to extract that patterns, and then based on that you create some output algorithms. That is a machine learning. Now deep learning is a subset of machine learning. Deep learning is one of the algorithm of machine learning. It's basically called as neural networks, but deep learning is focused about more on unstructured data. You can use deep learning for doing voice recognition. You can use it for speech analysis, image transformation, image detection. All this stuff you can use deep learning algorithms. Now, the deep learning algorithms, you have large volumes of data, greater parameters to train, it needs larger compute systems. It would require GPU systems to train upon. So all those things will be involved in deep learning, right? I hope you are able to understand the distinction between artificial intelligence, machine learning, and deep learning. If you have any questions, please put that in the chat window so that I'll be able to look at the questions and then answer them accordingly. I'll just want to give a small pause before I go forward. Any questions so far? I hope you guys are able to understand the flow. Okay. Thanks. So thanks for responding. Let us get into the applications of data science now. Because these are the first few sessions, we'll keep it more general. Uh, Initially, data science started with these marquee companies like the big ones, big tech giants like Facebook, Google, Instagram, Twitter, right? LinkedIn. So all these companies, what they've done is they have revolutionized the way in which the data analysis was happening. Prior to this, data analysis was happening, but it was more confined to the structured data. But with these companies, the data which was captured was different. For example, you take Google, the data which was captured was the web pages which need to be indexed and served in sub microsecond time means, right? So it's a very tough problem to understand. So there are millions of web pages, and if you're searching for a word called as career, then it has to provide us the links related to career, right? So it's a very tough problem to solve. And what these companies have done, it because they can't store the data in relational databases, they have invented systems in which they can store data effectively and do data processing effectively. So these companies, what I would say is they have revolutionized the way in which data was stored, data was processed, and data was consumed. All these companies created a lot of open source tools which were used by other companies to make the data analysis much more faster. Once these companies have created such of tools, for example, a very common example is Hadoop for big data analysis. So Hadoop was the mo- was the tool which was used for doing distributed computing. A lot of distributed computing was done on Hadoop systems. Now, once that was rolled out, there are other companies, for example, especially the banks and insurances, they have already having this predictive analytics capabilities. Now, predictive analytics is nothing but given input now, can we predict future based on the current circumstances of data. So based on the current circumstances and based on the current patterns of the data, is there a way to predict future? So these companies have created algorithms in such a way that it can look at the current data and then do the predictions. Now they have used large volumes of distributed computing like Hadoop and other things, and then they actually speed up the predictive analytics capabilities. The predictive analytics capabilities were only confined to data scientists' laptop or desktop. They were only confined to smaller development machines. But because of the advancements in distributed computing, now these companies can leverage bigger compute capacities and run bigger algorithms. Another interesting use case is on fraud and intruder detection. Now, what do you mean by fraud? Fraud is nothing but it's an anomaly which didn't happen or which doesn't happen regularly, right? So there were algorithms which are designed to identify such kind of anomalies. So if you take a regular behavior of data, you see that it is confined to a specific range of operations. So you see that there are certain range of operations happen, but if you see anomaly is something which is a little different from the regular set of operations. So if we can identify that kind of anomaly, there are a lot of anomaly detection algorithms which were created to identify such kind of anomalies, and then based on that you can identify the transaction, you can identify the intruder or some kind of defect which was identified. For example, I am a regular customer, I am a regular user of credit card. Imagine my regular lifestyle will be like, you buy groceries once in a while, I go to movie once in a while, I might be filling fuel or going for shopping or something like that. So this is the regular lifestyle. But imagine there was a sudden high value purchase. Maybe say like I have purchased a big 4K television, and then which costed me a lot, which is not which is not my regular pattern, right? My regular pattern, if you see, it will be more of a grocery shopping, fuel, restaurants, sometimes movies. So this will be my regular purchase pattern. But if you see, this 4K television purchase is completely different from this pattern. So technically this is called as an anomaly, and many algorithms were designed to identify such kind of drift in the purchases or drift in the behavior of data, so that we can identify such kind of transactions as either fraud or some uh, ill transactions. Now, you might, in the olden days, you might get calls, right? Sir, uh, we have seen that there is a transaction done by your name, by your credit card of so and so worth and so on, right? And please confirm whether that is you and all. So nowadays, there are automatic systems, there are automated systems which does the calls, or you might get message or alerts, or probably you might automatically block the card also for such kind of alerts, right? Only after you authorize the transaction, the transaction will go forward, or else it gets automatically blocked. So such kind of systems are in place which can detect such kind of changes. Another interesting use case is on sentiment analysis. Now, what is sentiment analysis? It's basically understanding the human sentiment, whether the person is happy, sad, uh, or there is a neutral sentiment. In initial years, we used to do a lot of sentiment analysis work for machine learning. People used to do natural language processing, and we used to work on these kind of use cases. But nowadays, we go more detailed because a lot of these retail websites, say Amazon.com or Flipkart or these kind of website, as you're seeing, they are too much of customer focused, right? A lot of business happens using the reviews, right? People, if you are looking at a product, first what they do is they go and check reviews. Same is the case for, see, even a movie or something, right? So if you want to go to book my show or whatever, you go there. First you check is the reviews, like how is the movie, uh, and only on the reviews you basically do some decision whether you want to invest your time, effort, money to go to the movie, or you just chill down. After a few weeks you'll get it in OTT, right? So the review processing is very important, and sentiment analysis is the core NLP engine which helps us to identify these reviews. But nowadays it is also going to the entity level. So review analysis go to the entity level and try to identify the feedback sentiment at the entity level. Now, what do I call by entity? Entity is nothing but it's the piece of information which is very specific for the product. For example, I want to buy a mobile. I go and look at reviews in Amazon.com. I want to purchase some decent mobile for my dad. Okay. So, I have certain peculiar requirements of how the mobile should be. But if I look at few of the reviews, there is one review which says that the battery backup of the mobile is great, the build quality of the mobile is excellent, the look and feel of the mobile is crisp, and it takes good pictures, but the front facing camera is awful. Okay, so there are 4 5 good comments saying that the build quality is good, battery backup is good, everything is good, but the front facing camera is bad, right? If my intent is to purchase a mobile for my dad, uh, he doesn't do any selfie kind of stuff, right? So his interest is not to take selfies, but he should have good battery backup, good build quality. It should last long, and even if you want to take pictures, then he will take pictures, but with the main camera, but not with the selfie camera. So according to the requirement, you can get to the entities. Now, entities for this particular condition is the battery backup, build quality, front facing camera, main camera, uh, other things, right? So these are all the entities for the product. And now the analysis went to the entity level so that you can analyze at the entity level which is good, which is bad. So it will give us more pinpointed information about which which piece of this product is good and which piece of the product needs replacement or maybe an upgrade. You might have seen that these companies would release a model, right? Say M20, right? So if they release a model M20, and after a few months they'll release M20s, right? So product is same, everything is same, but only there will be a minor change. Maybe previously there was a 1 megapixel front facing camera, but now they have revamped and changed it to a 20 megapixel front facing camera, right? Even people are going to 48 megapixel, even bigger ones, right? So that is how the sentiment analysis helps us, and from both from customer perspective and also from the manufacturer perspective, these review analysis helps a lot to identify the goods and the bads of the product. Another interesting use cases of data science is the self-driving cars, right? You might have heard about self-driving cars. You might have also seen them, right? So the cars like Teslas, Volvos, and other ones are providing self-driving cars which can drive by themselves. But if you imagine how this self-driving car works, right? It's very very tough for the self-driving car to drive by itself. There are a lot of set of rules it has to follow. There's a lot of sensors. There's a lot of cameras. All those camera sensors will send information to the central system. Based on that, it has to take decisions, for example whether it has to brake or whether it has to accelerate, and when to brake, and maybe a human common sense also need to be embedded into the car, right? A lot of these things are being currently being tested. A lot of work is happening in this space. It uses a technology called as reinforcement learning. Reinforcement learning, what it does is it tries to provide more of a feedback kind of mechanism where the feedback will be provided to the central system, and based on that, the model improves over time. So we'll look at some of the scenarios as when we discuss the detail of reinforcement learning. But this is a system which provides that kind of a feedback. One of the prime application areas of machine learning are called as classification and clustering. Classification is typically like segmenting the data into certain kind of classes. For example, if you want to look at a tumor cell and determine whether the tumor cell is cancerous or non-cancerous, or for example, malignant or benign. Now, how do I determine a cancerous cell as malignant or malignancy, right? There are a lot of parameters. Now, if I can train a computer vision model which can look at the intricate details of the cancer cell and determine the patterns and then come back with a prediction whether it is malignant or benign, Such kind of example falls under classification use case. There is another use case called as clustering. Clustering, as the name suggests, it is basically grouping the data. Now, if I wanted to identify the purchase patterns of users, and based on the purchase patterns, I would like to provide discount coupons. Now imagine there are tech geeks who are purchasing some new tech products. So every time a new tech product comes into the market, these are the ones who go and purchase those products. Or there can be some regular people who are like or regular grocery buyers in the same shop, right? So if you want to give discount coupons, you give discount coupons like 10 rupees off on certain product or certain grocery item to the tech guys, they certainly will not be interested. At the same time, if for some regular buyer you say that there is 100 rupees off on this new release tech gadget, again the regular buyers will not be interested. So you have to design your discount processing in such a way that it is much more focused to the group which it has to reach. So clustering is one of the technique which helps us to identify similar patterns by which we can make similar grouping, and based on the patterns of the grouping there will be decisions which will be made, whether this is a group of customers who are doing regular grocery shopping, or whether this is group of customers who are doing tech gadget shopping, or this is the group of customers who are doing cloth clothing shopping, right? So it depends, right? The people will can be a mix of both, but we try to create such kind of groups so that we can do the prediction. Another set of things, for example, recommendation engines. Now recommendation engines are very popular nowadays, that it is used in every industry. Primarily if you see the media industry or the retail industry, these are the core engines which are used to drive business. Now, what is the recommendation? Recommendation tries to identify similar patterns and identify the associations between the product. When you have a very strong associations between the product, then we can easily do something called as upsell or cross sell. For example, you identified that people buying a book purchase a product A or also purchasing a product B, right? So if you identify that there is a very strong association between the product A and product B, you can recommend product B for people who are buying product A, and then saying that you might like this book, right? So you might have seen that people who bought this also bought this and this, right? So you purchase a mobile, and you see that there will be advertisement saying that people who purchase this mobile also purchase this case and scratch guard and so on, right? So that is because of recommendations. You also see the recommendations in the media industry. Netflix is one of the most important users of recommender systems. It has a very minute grain of recommendation, based on your uh, viewing history. There's a lot of recommendations happening based on that. So likewise, there are other companies which are adopting to the recommendation engines, and data science as a whole plays a very vital role as a backend engine for doing these recommendations. Next, another use case for data science is transportation and car sharing. Now, transportation, again, the industry at least got revolutionized the way in which it works with the advancements of car sharing or car transportation companies like Uber, Ola, Flight, and Gojek, and there are a lot of other companies, right, which basically completely changed the way these businesses happen. And what they adopted is they adopted pure data related problems. They identified data as a core essence and build systems and algorithms around it, and kind of used it as a major tool for doing their business. If you see Uber, it leveraged the surge pricing purely based on the demand and supply. So if I can simply identify the number of transactions coming in a specific area in a specific time, I can identify that there will be a surge, and based on that, I can bump up the prices. Imagine every day in the morning and the evening, imagine it is a IT corridor or a financial district or some busy corporate hub. And from there are bookings happening. So imagine every day 5 p.m. to 7 p.m. there will be bookings happening from this area. And with my past historical data, I was able to understand that pattern. Then what I can do is, starting at 5 o'clock, I can bump up the search prices so that whoever books the whoever books the cab during that time gets a higher price. Now people want to book the cab because they want to go home, so they irrespective whether the price is like 100 rupees or 120 rupees, they'll still go and book the cabs. So that is a phenomenal change. Using the data, the companies like Uber, Ola, and other companies have actually used this kind of mechanism um, for adopting that change. One other interesting use case is on human emotion analysis. Now, this is basically to identify the human emotions. Now, in the future, I'm very positive that there will be a lot of uh, systems which are self-service based systems which will be incorporated, and most of these systems will be deployed wherever there is a customer service which is required. For examples, in hotels, uh, in airports, or places where you just do not need a human intervention, where we can directly go and talk to a system and then can get us some feedback. Such kind of systems will be equipped with this human emotion analysis, because we need to understand a human emotion while responding as well, especially in the customer service business. So these kind of analysis can be incorporated in those areas. A lot of work is happening in this space, especially using deep learning. We will be able to identify human expressions and do analysis based on that. Next one is genomic data analysis. Now, genomic data analysis involves uh, a, in an application area called as drug discovery. Now, drug discovery is very tough thing, because imagine like COVID came, and we have to invent the vaccine. But if you go and do research, like how much time it would take to get a vaccine out in the market, it is somewhere in years, right? So COVID was an exception. People were able to speed up the vaccine very quickly. But in ideal cases, the vaccine would take anywhere from 3 to 5 years to get the vaccine out in the market. But the reasoning for that is that we need to identify whether the vaccine is effective or not. And there are a lot of tests which will be conducted to ensure that the vaccine is effective, because I can't go and directly test the vaccine on humans. It can give adverse side effects. So we don't want to do that. So what the general drug companies will do is they will do a lot of tests on animals, right? So there can be rats, rabbits, monkeys, and different animals will be first tested to check whether the drug is effective. If it is effective, then it will be adopted to clinical trials, and then eventually it will be released in the market after certain approvals. Now, this entire process takes a lot of time. So, in genomic data analysis, what we do is we try to identify the patterns of the data, For example, if I want to identify the similarities between a mouse and human. Now, mouse and human, you might ask, like, what are the similarities? There are no similarities, but there are similarities. Mouse can see, mouse can smell, it will eat, it has mouth, and all that stuff, right? There are certain things which are similar. So, from a gene perspective, you would see that there will be similarities, and genomic data analysis identify those gene patterns which are similar. And if we do analysis of the drug on the gene patterns which are similar and identify whether there is a positive impact or a negative impact, based on that, the based on that, we can identify whether this drug will be positively impacting the humans or not. So it actually cut down the entire drug discovery cycle by many months and if not years. That actually has given a lot of push for faster drug discoveries and better vaccine creations. One of my interesting area is Internet of Things. Now, Internet of Things is also a very widely used data science application where we are trying to identify um, machines. Like now, we connect machines to these devices, and those devices are connected to internet, and they can transfer information from the machines to the internet to a central system where a lot of data analysis happens, and based on the data, you try to take some decisions. Imagine I want to do something called as preventive maintenance of uh, mechanical machines. So these mechanical machines are connected with a lot of sensors. We have acceleration sensors, gyroscopes, and a lot of these kind of sensors. All the sensors, what it will do is they will sense the information and can send it to a central system, and the central system will be able to make decisions whether a specific machine is going bad, whether we have to change the lubricant oil in the machine, or whether we have to change the ball bearings or whatever, right? See, all those things it can identify based on the pattern of the data. So there are a lot of mechanical or manufacturing companies, I would say, are incorporating Internet of Things, where you can adopt these kind of techniques with the combination of IoT and data science. There's a lot of work happening, and we can use that for doing a lot of cool stuff. Preventive maintenance is one of the commonly used one, but there are a lot of other things which can be done. So Google Cortana, of course, we know we have discussed the same kind of applications when we were discussing the voice, um, audio data kind of things. So these are the cool applications which are now provided, where even a kid, if he or she wants to search internet, he or she doesn't type, he just goes and clicks on the Google voice button and then searches accordingly. So that's the way. There's a lot of adoption in the tech, in the voice and audio space, and these are the tools which are heavily used. Personalized medicine. So this is also one very important area. Healthcare is a major adopter for data science. It is trying to identify that how we can use data science to identify personalized medicine. Now, personalized medicine, in sense, we try to use the techniques like clustering, grouping, segmentation, and so on, and try to identify the group of patients who behave similarly, who have same body habits, who have same height, weight, metabolism, blood sugar levels, and other kind of body vitals. So if you can find out the patients who are similar and can identify the patterns by which the diseases can be cured for those kind of groups, or the cause of diseases for those kind of groups, then we can adopt something called as personalized medicine. The medicine will be much more personalized to the user, or to the patient, and it will not create any adverse side effects, because of the wrong medication. So using the techniques in data science, especially the clustering techniques, the segmentation techniques, a lot of applications were created in the healthcare space where we can use this personalized medicine for doing a lot of data analysis, right? So what we have discussed today, we spent like 50 minutes on this topic. So what we have discussed is that how how data science is used in all these application areas. We might have got a quick overview about what were the different application areas and how we are using it in our day-to-day lives, which is backed up by data science. So over the course, we will be going through different topics, which will cover right from basics to the advanced topics to see like how we can create projects which will be used in these particular areas, right? Any questions on this what we discussed today, guys? Are you guys able to follow? Okay. If you have any general questions, do let me know. You could put in the chat window or speak up. We can discuss, or else we can wind up the session. Generally, my pattern of the session will be like 45 minutes to 15 minutes of content, and then we'll be giving around 5 to 10 minutes for any question answers, and then we'll close the session at a 1 hour mark, give and take. Yeah, I'm sorry, I stopped somebody. Was there a question?
Well, that's okay. No question, Ashwani. I really thank you for the general overview for a newcomer. This really gets the point across on where data science is being used and how. Thank you again.
Thank you, appreciate it. So just to give the way in which the session happens, so we'll cover like 45 to 50 minutes of content, and you'll have few minutes for question answers. Uh, Mostly our sessions will be an 1 hour long. So give and take 50 minutes plus or minus 5 minutes, like that is how the session duration would be. And then going forward, we will be getting into more technical things. So this was more of an overview. So this week, probably tomorrow or day after, we'll have a little overview of what is machine learning, and then what is the path in which what is the path. I'll kind of explain like what we will learn first and what we'll learn next. So it give us a sense of understanding that how will the how will the course will be progressing. We would also be touching upon some important areas like data science, machine learning, ML ops, how all these things are used in the industry. So we'll talk about few of those areas, and eventually we'll get into Python. Then we'll get into machine learning and other topics, right? All right then. So if you don't have any other questions, we can close the session here. I'll come back tomorrow at the same time. Hope to see you again.
Is it every day or every once a week?
It's every day. So every day, my time 6 o'clock, 6 o'clock in the morning to 7 o'clock. That's
Okay.
close to 7 a.m. Depending upon your time zone, right? So you might be in, not sure, you're in
Right.
US, you might be in UK, right? So depending upon your time zone, again, it is EST, CST, PST, whatever. So
And how many
it has.
sessions have you planned for this?
Generally, this course will be 2 month long.
Okay.
So if you take give and take, it would be like 10 weeks. Uh, if you say like number of sessions, say 50 sessions, 50 to 60 sessions duration.
Got it. Thank
A
you.
50 60 hour course, you can say, like it's a 50 60 hour course, which covers about the topics of data science, machine learning, a little bit of deep learning, and then ML ops. These are the concepts which will be covered.
Sounds good. Thank you.
We have done a demo session. I'm not sure if you guys have attended, but if not, get the demo videos from Career IT. They'll be happy to share the videos. That was talking about the end-to-end life cycle of data science. Um, so you can go through it and then can get a little more understanding as well. All right, then. Have a nice day. I'll talk to you tomorrow, same time. Bye bye.